What's up, guys? Christian Hodosy. I'm in your stats class. Obviously, I'm going to do this video homework solution. So I'm supposed to assume that my reviewers have already read the problem, so we're just going to get straight into it. Except we're doing a two-sample test here. We're just comparing gender, male and female, with the minutes of television per week listed here. So assuming that, we're going to have to make some assumptions here, and our assumption is going to be they're just simply independent of one another. Got to do that always when you're doing a two-sample test. And then we're going to do our grouping or factoring variable when we do our fit by yx. So we're going to do our x factor as gender, and that's going to be our categorical variable. And then we're going to do the response variable, or our y, which is going to be the minutes of television per week. And this is a numerical value. You can differentiate them by the categorical value being red and then numerical being blue. So we're going to do an EDA that's just looking at comparing the distribution to one another, looking at density estimates, looking at the box plots, looking at the mean standard deviation. So you can do that by just going on our fit by y by x. As we can infer here, female 123, male 152. You can do that, look at the means and look at the standard deviations. You can look, they're quite different actually. And then you can also and then go under our distribution. We can look on our EDA and compare the goodness of fit test to see if they're normal distribution. So we can scroll right here. We're under females watching TV, and it's going to be a 0.01 p-value, so lower than 0.05. So therefore, it's not a normal distribution. We're going to go on our males watching TV. Goodness fit test 0.0100 as well, so less than 0.05. Therefore, not normal. And then actually, if we go on our fit y by x again, looking at the graphs, we can infer box plots going up. We can infer that skewed right. Both pretty similar in values. Can see they're have some outliers, but they do look like they have differences. Their standard deviations are quite different. So we can just go straight to the unequal variances test, and we're going to look for that Levine value. Gives us less than 0.001 p-value. By that, we're going to reject our null hypothesis that they are equal, so we can infer that they are unequal variances, and through that we can perform our actual hypothesis test, which we're looking for, which is the means, which is mean 1 minus mean 2 equals 0, and then mean 1 minus mean 2 does not equal 0. We're going to assume that our mean 1 is going to be females, and then our mean 2 is going to be males. So because we're assuming that they're unequal, we can use the t-test over here. We're going to use the pool t-test when they are assumed to be equal, but they're unequal. So we're just going to look at our p-value right here. Since our alternative hypothesis does not equal 0, we're going to look at this value right here. It's also less than 0.0001 p-value, so we're able to reject the null hypothesis, and we're able to conclude that we can conclude the mean of females watching TV per week in minutes actually, and the mean of males watching TV per week in minutes are not equal. Thanks, guys.